All right, we're looking at lesson 1-3 in Algebra 2. So this is on limits. Before we start with limits, we're going to talk about shifted geometric sequences. Shifted means it's moved. In this case, it's going to be like plus or minus. And then geometric is just like in our previous section, geometric where it has a ratio. So a shifted geometric sequence is going to look like u sub n equals r times u sub n minus 1 plus d, where d is still the common difference. And r is the common ratio. Basically, we're looking at a combination of the two types of sequences we had. Previously, we had a geometric sequence or an arithmetic sequence. Now, if you put both of them together, where you multiply and you add, we have a shifted geometric sequence. The second thing is long-run value or limit. Sometimes it's also called long-term value. But they're all the same thing. Basically, what it's saying is where a sequence, I should be more specific, where a shifted geometric sequence is going to level off or plateau. So if you want a kind of a visual of this, what it's going to look like is, here's your limit. Things are going to start growing really quickly, and then they're going to kind of level off right there. There's a formula for this. The way to calculate it is limit equals restock divided by percent lost. Okay, we'll come back and revisit this in a second, but this is pretty important formula to help us calculate the limit. It's kind of like if you imagine our human population is eventually going to reach a limit. So we're growing really, really quickly, but eventually we're going to run out of resources. And so we're going to taper off. Like the death rate and the birth rate are going to offset one another, and we're going to keep a relatively constant population. So if we look at an example, here's one. It says the Osborns have a small pool and are doing a chlorine treatment. They initially provide a, quote, shock treatment and then add a small amount each day thereafter. The amount of chlorine is measured in grams. The recursive formula that models their treatment is this. We want to do a couple things. Explain the real-world meanings of the values 300, 0.15, and 30 in the formula, and then describe what happens to the chlorine level in the long run. So if anyone's ever owned a pool or swam in a pool before, they have to shock it at the beginning of the season. So they just dump a ton of chemicals in to start, and it kills everything. They let it dissipate for a little while, and then daily they'll add treatments to make sure that the chlorine stays at an even level. So the things we're supposed to define here are 300, 0.15 or 15 hundredths. I'm going to add one. I want to talk about 0.85. And then the last thing is 30. Okay? So u sub 0 is where the 300 came from. And that's always our initial value. So when we're talking about this chlorine treatment, this is the shock treatment. That's how many, gallons, grams? Measured in grams. So this is the chlorine treatment in grams. So they put in 300 grams to shock it. Then this represents our ratio right here. This has always been our ratio. And if we have 1 minus something, that means 100% minus 15%. 15 or 0.15, that means 15% is lost. It either just kind of disappears, it serves its purpose and goes back out into the atmosphere or whatever, but they lose 15% of the chemicals. 0.85 is 85%, which is the amount that's kept, I guess. 85% is what is kept. And then 30, that's the little addition on the end here. That's that common difference that we kept talking about. And it's just like a consistent plus 30 every time, every time, every time. That's the each day thereafter, every day, every day, every day. So this is the daily treatment. So the second question is describe what happens to the chlorine level in the long run. They want us to calculate the limit. This is something that they definitely calculate. I mean, people that own a pool won't calculate it because it will already be on the container of chlorine provided. It'll tell them how much to add based on the size of their pool. But the people that created those chemicals and created the manufacturing and everything to sell to their customers had to calculate this. So limit is the restock amount divided by the percent lost. So for us, the restock is 30. It's this number right here. That's what's being restocked or put in again and again and again every day. The percent lost is 0.15. It's got to be the percent lost as a decimal. So 30 divided by 0.15 is 200. So that means it levels off at 200 grams. They want 200 grams in the pool at all times. That's kind of the objective or the goal. So here's a different one. This is not in your notes. It's not in your notes, but just listen if you'd like kind of a more realistic example or maybe something you can comprehend a little bit better. Medicine acts in the same way, and your kidneys clean things out of your body to make sure that your blood is clean, your systems are working, like they just clear stuff out. So this says, suppose a human kidney holds 1 liter of liquid, which is filtered, removing impurities. Let's say 16 milliliters of medicine is introduced into the body, and the dose is not repeated. So like you have a headache and you take a pill, you take it once and you're done. So it says, assume the kidneys filter out 25% of this medicine each day. Complete this table to record the amount of medicine in the blood over several days. So day one, there's 16 milliliters in there because you took 16 milliliters. If you lose 25%, that means you maintain 75%. So 16 times 75% is 12 times 0.75 is 9. 6.75. So we've got 12, 9, 6.75. Let's do one more. 5.0625. So day 2, you've only got 12 units left. Day 3, there's 9. Day 4, there's 6.75 units. And then by the 5th day, you're down to a little over 5 units of the medicine. This one asks us to write a recursive formula that generates the sequence. So U sub 1 is 16. U sub n equals U sub n minus 1 times 0.75. So I always do it times the amount that we keep. Question is, how many days will pass before there is less than 1 milliliter of medicine in the blood? So we're looking for a decimal smaller than 1. So this is 5, 6 days, 7 days, 8 days, 9, 10, 11 days. So 11 days is when we'll have less than 1 milliliter. It says, is the medicine ever completely removed from the blood? Well, technically, no, because if you keep hitting enter on your calculator, there's going to be some tiny, tiny number. But yes, in reality, it is gone. Mathematically, it's not, but in reality, it is. Step 5, 1 dose of medicine is usually not enough. Like you have a headache, you usually have to take more than 1 pill. If the 16 milliliter dose is instead given once per day, how does this change the recursive formula? So what we had was U sub 1 equaled 16, U sub n equals 0.75 times U sub n minus 1. This time we're going to do plus 16 because we are adding an additional 1 per day, an additional 16 milliliters. Then this says what happens to the level of medicine in the blood after many days. So they want us to find the limit.